Well, welcome back, ladies and gentlemen, and let us get started with the last part of our Unit 3 here, and that is a discussion of the periodic table and periodic trends. Good. So to start with, let's go with this Consider aluminum. Okay, great. In which period and group on the periodic table will one find it? Okay, I think we need to learn some things about the periodic table, right? So let us make a few notes. Let's go with the periodic table. And I guess one place to start, as you guys all know I love to start, is let's think about a definition. What's a definition for the periodic table? Well, there are several, but I'd go with just this simple one. It is the arrangement of elements in order of increasing atomic number, right? An atomic number, as we remember, is number of protons. So really the periodic table is an arrangement of elements based on their protons. Good. Now, let's talk about a brief history, and we're talking about very brief here. Mainly, I want to point out to you that most people consider Dmitri Mendeleev as the father of the modern periodic table. Father of the modern periodic table. Now, that's not exactly the periodic table that we use because he based his on increasing atomic weights. Okay? He based his on increasing atomic weights. Ours now is based on increasing atomic numbers, so there's a slight difference. But by and large, the Mendeleev periodic table was the layout which led to our current periodic table. And since then, there have been other things changed about the periodic table, but by and large, Mendeleev was the father, based it on increasing atomic weights, and now we've switched it to increasing atomic numbers. Good? Okay, so now let's talk a little bit about the layout. Okay, so what is the layout? How is it arranged? Okay, well, to talk about the layout, let's actually pull up a periodic table. Good. Well, we essentially have two main ideas, I guess you could say. We have columns here, and these columns are known as groups or families. So this would be group 1, group 2, group 13, group 14, group 15. You might even call it the fluorine group or the oxygen group, and the groups go down the column, right? Good. And then periods are what we have that go left to right, that go what? Horizontally. These are called periods, right? So we have the second period, the third period, the fourth period, the fifth period, and the sixth period. Got it? And so that's kind of the overall layout of the periodic table. We go to our question now. Consider aluminum. In which period and group will one find it? I think we can answer our question now. Where's aluminum? Here is aluminum. What group is it? Okay, I go up to figure out the group. It is in my 3A or 13. Let's call it 13. So it is in group 13. And what period is it? Okay, period 3. So it's period 3 in group 13. Period 3 in group 13. All right, great. Okay, let's see if you can handle magnesium. Pause me, and when you have an answer, bring me back. Okay, magnesium. Let's take a look at magnesium. Let's clean that up a bit. Where's magnesium? Here's magnesium. It's in what group? Group 2. And what period? 3. So magnesium is group 2, period 3. All right, this is a piece of cake. Great, let's move on. Consider cadmium. Is it a transition metal, a main group element, or an other metal? Okay, we need to go in and go back to our periodic table and put in some more nomenclature here. Okay, well, we have our groups up top here, right, that are columns, but several of the groups have names. So my group 1 is called the alkali metals. Group 2 is called the alkaline earth metals. The D block here, and some would also include the F block. It all depends on your perspective here, but the D and F block, it depends. Some people call the D block the transition metals. Some call transition metals the D and F. For our purposes, we'll call the transition metals D and F. Like I said, it all depends on the book you have. We're going to say that the transition metals are D block and F block metals. Over here, we have, this is what we call the halogens. Halogens, they're group 17. And group 18 are my noble gases. Noble gases. Okay, what else do we need to know? Main group. Main group, hey, look at this. I even have it written on the periodic. Main group elements are my S block and my P block. So main group means my S and my P block. And then we have a group called other metals, right? Because where are my metals? Well, here's a metal, and here are a set of metals, and here are metals. So my S block, so my metals would be what? My S block, my D block, my F block, and there are some metals which are in my P block. And these are guys we call other metals. So the other metals are my P block metals. P block metals are my other metals. So when I say, hey, where are my metals on the periodic table? You can say, hey, S block, D block, F block, and the lower section of the P block make up my metals. Okay? I think we have enough now to answer our question. Cadmium, is it a transition metal, a main group, or an other? Okay, let's see. Where is cadmium? Cadmium is right here. What do you think? Well, it's certainly in my D block. Is it part of my main group? No, my main group are S and P. And is it another metal? No, my other metals are my P block metals, right? So cadmium is simply a transition metal. Okay, good. Here we go for you. Think of 10. Is it a transition metal, a main group element, or an other metal? Okay, pause me, and when you have an answer, bring me back. Okay, good. So let's find out. We need to find 10. Where is 10? Let's clean that up. Where is 10? Where's 10? 10 is SN right there. There's my 10. Okay, so first of all, where is it? Well, it looks like it's in the P block. It's a P metal, so that would be an other metal. But notice, it's also in the P block, which means it is a main group. So it really is characterized as two things, right? It is a main group element, and it is an other metal. So, oops, it's cadmium. Sorry, wrong one. Yes, it is a main group. 10 is a main group element, and and other metals. So 10 is considered both of those. Whew, great. All right. Moving on, consider the ionic compound MgCl2, magnesium chloride, right? Identify another element which will react in a 1:2 ratio with chloride ions. Well, what did they tell me? They say that this means I have one magnesium and two chlorides, and really that's a 2 plus and a minus, and we'll get into that later. But it says that there's a ratio of 1 magnesium to 2 chlorides, and we are to find another element that'll act like magnesium. Well, I mean, I wish I had a way to figure out what else would act like magnesium. Well, we do, and it's our periodic table. There's something here called the periodic law. Okay, now I recommend that you memorize this, well, pretty much word for word. The periodic law, here it is. When elements are arranged, in order of, increasing atomic number. That's the way the periodic table is arranged, isn't it? When elements are arranged in order of increasing atomic number, comma, there is a periodic repetition of chemical and physical properties. So this is the periodic law. When elements are arranged in order of increasing atomic number, there's a periodic repetition of chemical and physical properties. What does that mean? What it means is when I arrange things, elements, in increasing atomic number, like the periodic table, like it is with the periodic table, there's a periodic meaning there is a cycle that a cyclic nature to the chemical and physical properties, or a repetition which we can predict. There's a predictable repetition of chemical and physical properties. Okay, that sounds a little difficult, but when we look at the periodic table, we'll understand. Let me clean this up a little bit. Zoink. Good, clean that, good. What we mean here is lithium has certain properties, okay? Lithium will react in a 1-to-1 ratio with chlorine. Lithium is a metal which reacts readily with water, okay? Well, everything else then that is in the same column as lithium will share those characteristics. So sodium, turns out, it is a metal that reacts with water. Sodium will react with chlorine in a 1-to-1 ratio. Potassium is a metal which will react readily with water. Potassium will react in a 1-to-1 ratio with chlorine. And the reason for this is not only do these guys all share the reason for this is these guys have the same number of valence electrons. They all have one valence electron, and that's why they will react in similar ways. Things here in my second group, my alkaline earth metals, they'll all react similarly, and the reason really why is because they have two valence electrons. And we'll get into the idea of valence electrons later. But the point being, elements in the same group, if they're in the same group, they're going to share properties. Okay, specifically, they will react in similar ways. So, when we looked at our question here, we said magnesium chloride. Okay, magnesium chloride. Where's magnesium? Here's magnesium. Magnesium chloride, we know that magnesium there'll be 1 magnesium to 2 chlorides. So what else will react with chlorine in a 2-to-1 and a 1-to-2 ratio? Well, we just said everything else in this column should act like magnesium. So I would guess that calcium would react in a 1-to-2, strontium would react in a 1-to-2, barium would react in a 1-to-2 ratio with chlorine, and I would be completely correct on that. I could also look at the other side and say, hey, you know, what else is going to act like chlorine? Well, everything in this column is going to act like chlorine. So I have a 1 to 2 ratio between magnesium and chloride. What about magnesium and something else? Well, do you think magnesium and 2 fluorines, or magnesium and 2 bromines? Bromides, we call them here. That is correct. Fluorine and bromine and iodine and astatine will all act in a similar fashion as chlorine does with magnesium. All right, cool. Boy, that periodic law is a nice thing, isn't it? Here you go. Consider the ionic compound rubidium sulfide. Identify another element which will react in a 1 to 2 ratio with rubidium ions. Okay, pause me. When you have an answer, bring me back. Okay, rubidium sulfide. Let's take a look at our periodic table. Let's find rubidium sulfide. Where is my rubidium? Here's my rubidium. It's a group 1. Where's my sulfur? Sulfur is a group what? A group 16. And what was my question exactly? I want to find another element which will react in a 1 to 2 with rubidium. So I'm going to keep my rubidium, and I need to find something other than sulfur that will react in a 1 to 2 ratio. Okay, here's sulfur, so what do you think? Well, you could have said oxygen or selenium or maybe even tellurium. These guys down here are metals. It's going to be less likely that they'll react that same way, but all these nonmetals and even the tellurium, which is a metalloid, will probably react in the same way. So I'm going to go with the easy one, oxygen. So I would predict rubidium oxide as an answer. Okay? Questions? Good, 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 good. Let's see where we are. I think that's going to be it for part 1. We'll catch you next time. Hi ho, ho.